So if you just watched the previous video, you notice that I kind of slipped a new functional group in there with the nitriles. We haven't really ever talked about nitriles very much in this class, but I do want to just kind of what are nitriles and why did they show up all of a sudden in this chapter is what we're going to kind of focus on in this video. There's not a whole lot of new reactions here. It's just kind of where do nitriles fit in on things. Okay. So if we think about what kind of reactions we can do with a nitrile, right? So nitriles, what's their deal? Um, a nitrile, again, is a carbon-nitrogen triple bond. We can add nucleophiles to the carbon, right? And that's it. So basically kind of reacts like a carbonyl, except there's no carbon-oxygen double bond. Instead, we have this carbon-nitrogen triple bond. So one of the most useful is if you add water and H+. So now take a minute, pause this video, think about what do I expect to happen if I add H2OH plus to this thing that's kind of like a carbonyl, but not exactly like carbonyl, right? Think about other reactions that we've talked about, maybe draw a mechanism, right? And just take a minute to predict what you think is going to happen. Okay, you're back. Good. What did you predict? Did you predict a carboxylic acid? Because that's pretty much what happens. You end up with a carboxylic acid plus ammonia as your other byproduct. And thinking about how this happens, of course, right? We're just going to add that water nucleophile to the carbon of the nitrile, break the pi bond, make a lone pair on nitrogen, and we're off and running, right? So what we end up with is, I probably won't end up drawing out the whole mechanism here, but you end up with something that looks like this. And notice that if we just switch some, so I'm going to move H plus around. And now all I have to do is draw the resonance form of this, and now I've got myself an amide. And we all know what happens if we take an amide and treat it with H2O and H plus, right? So if we take an amide and treat it with H2O and H plus, that's one of our reactions off of previous lectures. We know that that substitution will convert the nitrogen we'll replace it with an OH and make a carboxylic acid. So really that first addition, adding the H2O there, makes an amide, and then the amide is converted into carboxylic acid. It's hard to stop at the amide because you usually have an excess of water around, and so water just kind of keeps adding. Although there are probably ways to do that if you want to, you can figure it out. But the important thing is that nitriles are basically just amides that have one less molecule of water in them, right? If we take a nitrile and add water to it, which is what we did here, we make an amide. And so with nitriles, we can kind of think of them as this kind of in-between state, right? So nitriles plus water make an amide, right? Amide plus water makes a carboxylic acid. Similarly, if we take an amide and lose water from it, so do a dehydration reaction, minus H2O, we can make a nitrile. So and it has to be a primary amide. If we take a primary amide like this and do a dehydration where we lose water, we can make it into a nitrile. Notice that we're losing 2 hydrogens from the nitrogen and 1 oxygen from the carbonyl. That's H2 and O. That's what makes up water, right? So nitriles are really just kind of almost amides in disguise in a way, right? They're amides that have lost a molecule of water. So if we add that molecule of water back in, we can make the amide and then convert it back to the carboxylic acid and go from there. So You will occasionally see nitriles show up in carboxylic acid problems. The main thing to remember is that that carbon is a place where we can add nucleophiles. So think about all the nucleophiles we've used, right? You can add water to it, you can add alcohols to it, you can add Grignard reagents to nitriles, right? All of those kinds of things are possible. So be ready for that. Think about what that might look like. What happens if I add a Grignard reagent to a nitrile? Right? Now, what does that process end up looking like? We know enough now to kind of figure that out without having to go through the actual mechanism. So that's a quick introduction to nitriles. As I said, nitriles aren't something that show up a lot, but occasionally they fit in, and they fit in nicely with the carboxylic acid chapter. So we're going to talk about them here. I think that's everything for this. This concludes lecture number 20, which will be everything that goes through the second exam. So everything up till now will be on the second exam. So look forward to that.